I'm a software engineer from a UK-based company called Adaptavist, um, and I need to give you a quick intro to who we are and why we're interested in types, which I think I might have covered yesterday, but for the sake of recording, I'll just go over it again. So we make products for Atlassian. Well, not for Atlassian. We make add-ons for Atlassian products like Jira and Confluence, and we have a product called Script Runner, which is allows you to automate Jira and Confluence and those products using Groovy. But the only problem with that is that you need to be an admin and you need to be able to program Groovy. So a couple of years ago, someone discovered Blockly when, from teaching their kids things like Scratch and Make Code and stuff like that. And came up with the idea that we could probably do this ourselves. We could use the block system to make it easier for people to create automations, so they didn't need to be an admin and they didn't need to know how to program that well. And so this product Autoblocks was born. After many naming decisions, we came up with a joke based upon Transformers, mainly so we could use the tagline "scripting in disguise." And it's not meant to be a teaching tool like many other block-based products. We're trying to help users just automate things themselves without them having to know how to program necessarily, and we don't expose them to the generated code. Excuse me. So it's kind of important that to us that our blocks connect properly, that you can't connect crazy things together. So having the type checking system that's provided by Blockly is quite important to us. And this talk is mostly about that, I've guessed. So if you're not that familiar with the type checking in Blockly, I'll just give you a quick intro. And it's what prevents you from connecting certain blocks together or allowing you to connect certain blocks together. So here's a couple of block definitions, and there's you can see on the left we have this mouth block with an input, and it has the list of acceptable types, food, drink, and then on the right we've got a block with an output with the types that it kind of supplies, and it's these arrays that we're concerned about. And it's all about Venn diagrams, Blockly checking. So it's when the types of the input intersect with the types of the output that the connection is allowed. So we put in the types from those blocks there. We've got this mouth block, and we've got air, drink, food there. We've got the peas, which contains food. So there's an intersection here. Then you can see from the tiny block at the top that we can drag that P up and it'll connect to mouth. But if you've got any children, you're probably more familiar with this, the fussy mouth block. Which is has a bit more specific requirement instead of food, and peas don't meet that requirement. So no matter how much you try, the peas will not go into the fussy mouth. And that's basically how Blockly does check-in. So we thought, oh, this is great. This is like everything we need. But unfortunately, it didn't turn out that way. We had a lot of issues along the way. So we'll go into that in a bit. But here's some examples of how our blocks use types. Excuse the color scheme. We here have a create issue block and a create subtask block. So if you're familiar with any kind of issue tracking system, just an issue like that, and then we can print out something at the bottom. So we've got that connection there, the project input that will accept a string or a specific project type, and the output block there is a string, so we can connect that together. And in this case, we've got a block that actually returns an issue type, so that we can plug that in because that input allows you to have an issue type or a string. So we can't plug in anything like just any old random number into that, or a project, or something that just doesn't work. And then we've got the variables. So the create issue block actually assigns the new issue into a variable, and that variable will carry that type of issue, so that when you plug it in, you can only plug it into somewhere that accepts an issue. In this case, the create subtask has that parent issue input, and that's where we plug in the issue. So that was the simple usage of Blockly, but when we came to using lists and loops, it turned out not to be so simple. So here we have a for each loop with a create list with attached to it, and we have no items at the minute, so we don't know what type the input should be. We don't know what type the output of the create list with is, and we don't know what type that variable is going to be. But the thing is that inside that body of the loop, we want to know what that variable is so that it doesn't get plugged into the wrong place. And so we want the types to flow from or infer. And so if you plug in, that issue there, it knows that the list is going to be of issues, and that the variable would be an issue. And also, if we've already got that issue there, it's like, what can you plug in? What else can you plug in then? And it's like, you could end up with a list of issues and something else. And the variable could have then multiple possible types, which would be a very messy situation. So we don't really want that to happen. It could get really confusing in the variable body. You would have to restrict the variable to allow a connection to inputs that accepted all of its possible types that the variable had, which is something that Blockly doesn't do. And also, not to mention that variables can't have multiple types anyway. But I'm going to come back to that one. So the remaining inputs of the create list should inherit from this first input. And that way, yeah, you can only add another issue in there. We can't just put in any old string or any number or project or something like that. So how do we implement this? There are two things that were required. Some concept of high types, or also known as generics or parameter types or container types, or depending on what paradigm or language you want to use, which allows lifting or wrapping of a base type in like an issue into a higher type, like a list. And also we created a custom Blockly extension called type from, which allows you to transfer the type from one connection to another, and optionally modify it by wrapping it in a higher type or unwrapping it from its higher type. And we'll cover the higher types first. This one's quite simple, actually. We use a high type in this example called list, but you can call them whatever you like. So you can just use this naming convention where you just say that this is actually the literal string that you can put into the check, list colon, and then a wildcard, which means that it will accept any kind of list, a list of anything. So you can put that in your for each input. And then if you wanted a specific list, so if our create with is returning a list of issues, you can say that it's a list of issue. Sorry, if the input wants a specific issue, you can say that you can only accept a list of issue. But if you're doing that, it's quite good for user experience to allow either one or many of these things. So if you put both in there, it makes it simpler. But your code generator needs to be capable of dealing with that. And on the output side, if you're returning a specific type, you need to declare both. You need to declare that this output can be attached to something that specifically wants a list of issue, or it can attach to something that wants a list of anything. And just by doing that, you can basically have some kind of rough generic type system with just what Blockly provides. So if we transfer that back to our Venn diagram, you can see that the for each accepts the list, and the create list with accepts the provides a list of anything, so you can connect the two together. While I was writing this, I came up with some other ridiculous ideas to make it all a bit more consistent, where you could have you could raise everything into a height type depending on whether it's one, many, or one or many, but your output type list suddenly becomes a bit crazy. We don't actually do this. It's just an example of how ridiculous you can get if you want. So now we have a way to represent more complex types. We need some way to update the type checking on the input, output, or variable based on something else. And this is where our extension comes in. And this is just similar to the list where we have this type. You literally put in from colon, and then you specify the input that you want to inherit that type from, and whether you want to wrap it or unwrap it from the high type, and the mystery operator at the bottom, which I can't remember what does at the minute. But this basically works by we had the extension. If you add the extension onto your block, it looks for this pattern in everywhere you can declare a type. And it overrides various internal methods of Blockly connection prototype and listens for connections and disconnections. And then it will replace these strings in the checks with the actual type. It's basically a massive hack, and it's probably something that we need to kind of request APIs for and discuss in a bit more detail. I've made the code available later. I'll put a link up. So here's how it appears in like a block definition. On the we've got in the for each loop there. You can see the variable type and the default type is going to inherit its type from the list input, and it's going to strip off the list prefix from that. So if you've plugged in a block on the other side that's got list colon issue, what it's going to return, those variable types will get transformed into just issue there. And that happens when you connect or disconnect. So all of the other type checking just continues to work. Then we didn't need to do anything with that. And on the other side, on the list create with, the output declares that it's going to derive its output type from the first excuse me, the first input, which is add 0, plus it's going to wrap it or prefix it with that list colon. And that was really nice. We were all really pleased with ourselves, this solution. And then somebody discovered a slight problem. So here's a bit of code. This is the real code that real set of blocks you can create in in our product. And it's this block here that we're interested in. You see, the idea of this is that this set block allows you to set a field in the issue, because during issues you can have many different fields, and we didn't want to have an input for every single field. So you can drag in these set blocks to actually set specific individual fields and then plug something into that. And in this case, components of the field is a list of things. It could be like label or versions or something like that, but it accepts a list of strings. So you need to kind of put in like a create list block. And that input there is at this point, it's specifically a list of components. And we expect that from that, you'd expect to just be able to connect components to it and not anything else. But at the minute you try to insert something else, like an issue type that's not a component, it just disconnects, and it's not like the experience we want. So what was the solution to this? We've not solved it yet. It's work in progress. But this is kind of my point, is that it's a bit of a rabbit hole. You can you think that you've got things sorted, and then there's a lot more going on. But hopefully, if anyone else is having these kind of issues, they can probably have a discussion about it. So the next thing is variables. Blockly already supports type variables, but the problem we have is that the internal model only allows variables to have a single type. And why is this a problem for us? First, it's kind of inconsistent with the support for multiple types elsewhere on outputs and inputs, so it becomes a problem when we use it with type from. Because if you say that a variable should inherit its type from something you've plugged in, and whatever you plug in has two types, it's like, which type do we pick? And we have valid cases for having multiple types as well. It's very specific to within it. It's in our use of event triggers. So we have this block here. So when an issue is created as issue, we have this variable issue1 here that has the type of issue and issue event. An issue provides all the normal stuff, like, the summary of it, the key of it, the description of it. And it's also got, we want it to have extra data like the issue event. So the issue event will have uh, extra properties like who triggered the event, what time was the event triggered, that kind of thing. Maybe even what the data was that's changed. So that variable can then be plugged into something else, like our getter blocks. And our get blocks, they adjust themselves based on what you've plugged in and the type of the input. So if it's an issue, it'll give you the list of all the properties on an issue. And if it's an issue event, you'll get the list on that. So we want the list to be like all the usual list of things like summary event. And we also want those additional properties like the instigator and the time that it happened. But the variable model doesn't support that. So we just do what every developer does and patched it. And this is, again, is a fairly horrible hack. Well, we tried to patch it, but in the end, we just ended up having to copy the vast majority of these bits of code and override bits. And there is an issue that I've opened. This is my attempt to explain this issue further, because I've just not had time to. I didn't really know how to explain it in detail, so I wrote a presentation about it. But I think it's totally backwards compatible. But obviously, we don't have any other use cases of Blockly to confirm that. We only have our thing. So I'll wrap this up now. Inclusion. Types are hard. And the current type system in Blockly doesn't cover quite a lot of cases. It's very good for some simple cases, but once you start having to transfer types around and infer types, the support's just not really there without hacking it in. And we needed a variable type model that was kind of consistent with the way that other connection checking worked. So there's some things that I'd love to work with the Blockly team on, and some or all of these things, maybe a standard way to enhance core functionality with, or plug-in points for the connections, and or maybe even just an entirely pluggable connection system, like with the renderer, so that people don't have to have the overhead of this complex type system if they really don't want it, because I know a lot of users don't need to have this. And that's it. Any questions? Well, no, it's well, at build time, when we compile it, we can handle it all fine. We have a conversion system that allows us to do that, but it's mainly just to prevent users from connecting stuff. So we don't want them to be using plug-in issues into where a variable or a block that returns an issue into something that can't cope with that. I mean, which is ideal which is perfectly fine if you create like a learning tool, because learning from these mistakes is exactly what it's all about, learning to program. But we're not trying to teach people to program, so we're not trying to teach them. We're specifically trying to hide the concept of types from our users by not having to worry about what they can connect to what. I don't know. Yeah, okay. Okay, great.
I'm not sure I understood what was the problem, the list type. The problem was that you tried to tries to connect the block on the wrong side to the list constructor. The list itself disconnects from the other block. Was that the problem? That you went really quick that oh, it breaks, and you said that it breaks.
Yeah, I'll go back to the slide. So this one here. Okay, so you didn't see why this was a problem? Why? Okay.
It disconnects at a different place and where you actually
Yeah.
this you consider quite confusing.
Yeah, because we got feedback that they knew that components had to be a list, so they'd put in a create list with connect it there, and then when you accidentally connect something else that's not that, it breaks it, which is not what they expected to happen. Was that you just couldn't plug something that was incorrect into it.
All right. So for the people watching this on YouTube later, so for me, it seems like you could have the things like the list block could have a type check function on it, which is already supported in Core Blockly, and it could look at the parent, which is the set components, and see that that's a list of needs a list of components, and therefore know that it should assert on each of its inputs that they must be of components. But so did you try that? Like, what was the reason for going with this approach versus so?
So sort of, you can do it in a roundabout way. There is a single function that does type checking that is public and can be overridden. So if you wanted to add it on a per block basis, you would override that function and say, check the block for a type check function. And then you would have to add that type check function to your block definition. So it's possible to do. It's a little roundabout.
Yeah, I think we wanted it to be as declarative as possible as well, really. So we don't want you could probably do it in a generic way, I guess, and have one function do that. But then we've got an extension that does it in a generic way instead.
Hi, I'm just curious if you guys explored any like visual indication of type for your users. Just like, did you try anything? Did you have any options you were considering?
Well, we considered, yeah, the amount of types that there will be eventually will just be enormous, and we don't want to concern our users there. We do, one thing that has become clear is that we need to explain to users why something can't connect or why something's been disconnected. That was one feedback we have, but that's on the backlog.
So I guess on a different project I used to work on, an approach I took to the disconnect thing that you're describing is that instead of forcing a disconnect to actually have like a warning pop up, So it doesn't necessarily disconnect the blocks, but then allows you to be able to basically show the user what's going wrong, so they know what to do and what to change. Within the context of Blockly, that's kind of it's kind of weird, because that ends up meaning that you end up having a lot of Blockly type checks that are null, so that things can connect kind of regardless, but then you have kind of a warning system on top of it that is then able to recognize what's going on. That could be a type of solution to what you're describing.
Yeah, that's an interesting approach. We definitely know that we need to do something better than what we currently have with this. But yeah, it's kind of part of why I'm talking about this, so I can get some other ideas.